Alright, in 10.6 we had area of a circle now, or circumference of a circle, which is the perimeter, and now we're doing the area. So the area is r squared pi. So their circumference is 2r pi, but the area is r squared pi. So you can remember that because r squared and the units are squared. So how much more pizza is a 12-inch diameter pizza than a 10-inch diameter pizza? So this is talking about area. So if the diameter is 12, the radius is 6, and this one has a radius of 5. So what you're going to do is compare 6 squared pi, so you're going to compare 36 pi with 25 pi. So I would subtract these two and you get 11 pi. So since we're talking about pizza, we don't want to answer with pi in it because we want to actually have the amount of inches. So in your calculator, just do inches squared and actually calculate 11 pi to the nearest inch. Alright, then area of a sector. So this is a sector right here. It's part of a circle. So the formula is you take the degree, so the central angle, divide it by 360, and instead of multiplying it by the circumference, which we did in arc length, you're going to multiply it by the area formula, r squared pi. So just like circumference, we had an exact value and the nearest tenth, we're going to do the same thing here. So exact would be the angle measure, which is 90 over 360, and then you multiply it by 4 squared pi. So 90 divided by 360 is 1/4. This is 16, so it's 16 over 4, which is 4 pi units squared. So to find the nearest tenth, so this is exact, to find this nearest tenth, put this in your calculator and round it to 1 decimal. Okay, this sector area is the degree of the angle that's shaded over 360 times the area of the circle. The radius is 6, so it's 6 squared pi. So this is 1/10. This is 36, so it's 36 tenths pi, which reduces to 18/5 pi units squared. And to get the nearest tenth, just put that in your calculator. Okay, this sector area is you're trying to find this angle. So this angle is 360 minus 45 degrees, which is 315. So the angle is 315 over 360, and you multiply it by the radius is going to be 3. So you're going to multiply it by 3 squared pi. So I'm going to take this and reduce this. 63/8 pi. It's a lot of reducing. Okay, then again, you need to put that in your calculator to get to the nearest tenth. So, to recap, we have, if you have a circle, we have an arc length, which is actually the distance. So you're going to use their circumference formula. We have a sector, which is a piece of a pie. It connects to the center. And the last part we have is a segment, which is right here. So notice a segment is if you take a sector, so this is my sector, and you cut off a triangle, then you get a segment. So find the area of each. So this is a segment. So we have to find the area of the sector and subtract the area of the triangle. So the area of the sector is a degree, so it's 90 over 360 times the area of the circle, which is 3 squared pi, or 9 pi. So we're going to reduce, so this is 1/4 So this is 9/4 pi minus the area of a triangle. So the area of the triangle is 1/2 base times height. So 1/2 base is 3 and the height is 3 because it's where it makes a 90-degree angle. So it's 9/4 pi minus 9/2. Now, because it reads around the nearest tenth, you're going to put this in your calculator, and then it's units squared, the nearest tenth, so 1 decimal. Okay, next example. So it's the area of the sector minus the area of the triangle. So the area of the sector is the degrees, so it's 60 over 360, times the area of the circle, which is 25 pi. So these cancel out. So 636 is 1/6. So it's 25 pi over 6 minus the area of the triangle. So in this one, you could calculate what the height is. This is actually going to be a 30, 60, 90. So the hypotenuse is 5. This has to be 2.5. So this is 2.5 root 3. So actually I'm going to do that. Or I was thinking use this formula. Use the law of sine, or the formula with sine area of a triangle. So it would be 1/2, 5 times 5 sine is 60. You can do that too, but I'm just going to do 1/2 the base, which is 5, times the height, which is 2.5 root 3. So in the end, you'd put this all in your calculator and then round to the nearest inch. And then the last one. Okay, so I'm going to do the area of the sector, yeah, minus area triangle to get the segment. So the area of the sector is, I know this says 60 degrees, but I actually want this degree, which is 120. So it's 120 over 360 times the area of the circle, which the radius is 4, so it's 16 pi, minus the area of the triangle. So I'm going to do this first. So this cancels out. This is 1/3, so it's 16/3 pi minus the area of the triangle. So I don't have this distance. I'm going to do, this one I'm going to do that sine formula because I know that this has to be 120 degrees. I know the radii are 4. So I'm going to do 1/2 times A times B times sine of 120. So this is the area of the formula, or area formula. You could also do special right triangles with this. This would have been 2. This height would have been 2 because this is a 30, 60, 90. Because it's a 120 cut in half, and this is a 90-degree angle. And this would have been 2 root 3, 2 root 3. So this is 4 root 3. So you could do that too, but I'm just going to show you both ways. So you put this in your calculator around the nearest inch, or nearest tenth, 1 decimal. So we have a sector. A sector looks like this. And a segment looks like this. And an arc length looks like this.